Hi, I'd like to take a look at a pretty typical question that we get in our physics class. Here's two cars that are approaching each other. They start 12 meters apart, and car A is moving to the right, and car B is moving to the left. And what we want to do is find out, I guess we could find out when they meet and also at what position they meet. So I would like to show you how to solve this problem using Python and glowscript in particular. So if I take a look over here, I rewrote the question here in green. The two cars are 12 meters apart. Car A moves 1.4 meters per second to the right, and car B moves 2.2 meters per second to the left. So I guess the first thing I need to do is make these make some objects. So cars, maybe they're going to be a box, and just to keep it real simple, I'm going to call the first box just A. So that'll be a box, and I'll give it a position. Position is equal to, remember it's a vector, and I will start it, I think I'll start it at 0. So 0, 0, 0. The other thing is we need to give it some dimensions. Here I'm going to hit enter so that it's a little bit easier to see. I'm going to say the length equals 1. And these are a bit arbitrary. The height equals maybe a half, and the width, that's the z direction, maybe equals a half. And I'll make this one blue. Color equals color dot blue. And I'm going to create an attribute here called velocity. And the velocity is only going to be in the x direction, so I'm just going to make it just a regular number. I guess I could make it a vector that has x, y, and z, but I'm just going to make it a 1.4. So that's the fact that it's moving 1.4 meters per second to the right, so I'm going to make that a positive 1. Okay, let's just see what this looks like. See if it looks like a nice box for our purposes. Oh, it looks pretty ugly, but I guess what I realize is that the screen hasn't, the camera hasn't scaled back yet. So I guess I need to make another box, and then it'll be better to tell. So I'm going to copy this and then paste another one. Oops, paste it. And I will make the second box called B. Now the difference is it's going to be 12 meters apart, so my X position is going to be at 12. I can make the length, height, and width the same. The color, maybe I'll make the second one red. And the velocity, since this is 2.2 meters per second to the left, I'm going to go with to the right is positive and to the left is negative. So over here, I'm going to change this velocity to negative 2.2. Okay, so now that I got two boxes and they're 12 apart, let's just run this and see what it looks like. That's not bad. I've got a little bit of I can move it around. So the blue box is at the origin, which is why that when I rotate things, it doesn't seem to move very much. But I can shift over. There we go. And see, give it a little bit of a 3D look to it. It's kind of cool. Kind of dark lit. All right, so I guess I'm going to have to create a loop. But before the loop, I should establish that I have a variable called time, and I'm going to start time at 0. I'm going to make dt the amount that time is going to be increasing by, the change in time or delta time. I found that 0.05 works quite well. And now I need to do a loop, so I'm going to say while. Well, when do I want it to stop? Yeah, I could, why don't I say while time is less than, say, 5 seconds. I'll go with that, and then I'm going to consider later on about whether or not I can just change time or whether there's some rule I can put in there. So I'll just put that fairly simple now. And you notice I did remember the colon at the end. And I need to slow this down, so I'm going to say rate. And you know what actually works well is if I change dt afterwards, if I make 1 divided by dt, that works out really well. So for example, in this one, example 1 divided by 0.05, I think that is what, 10, that's 20, would be equal to 20. So I'll try that, because that way if I change dt, obviously my rate will change as well. So the smaller I make dt, the faster that rate will work. So hopefully it'll be pretty close. 1 over dt would be like as if it's live. So if I'm going to say, well, time equals 5 seconds, as long as my computer can keep up, it will actually be a real-time 5 seconds. All right, so now this is the time for our mathematical or our computational model that we need to keep track of A and B at the same time. So you remember, the model was, I'll just put a hashtag over there. It was x equals v times dt plus x, where x is the position. But it's a little bit different because I've got the boxes here. So what I'm going to do is, instead of keeping track of x, I'm going to be putting that a dot position in there every time. So I'm going to say the x position for box A will be x dot position dot x. So far, that's this part right here. That's just that x is equal to, now the velocity for box x is this velocity 1.4. So I want to reference that. So it's going to be a dot velocity times how much time goes by? dt plus, now I need to add that x again. So it's going to be a dot position dot x. Whew, that's kind of a mouthful there. So this line is this same model, except for it's just for object A, for car A. And if I want to go and change the velocity, I will change it here. If I want to change the velocity of B, I'll change it there. If I want to change the starting positions, I'll change it here and here. Okay, so now my second one, it's going to look the same. So I'm just going to copy this. I got to make the tab properly there, and now I got to change my A's to B's. Oops. Okay, and I guess I also need to make sure that I increment time. So time is equal to time plus my change in time. All right, let's try this. Let's run this program and see if it works. Probably going to get an error. Oh, got an error. Yep. Cannot read property vel of undefined. Okay, so let's go and see what I did wrong. So that is at or near line 29. Oh, I did a little error here. So I'm going to say b dot position dot x equals b dot velocity times. Maybe that will work. Let's just see if that'll work now. Oh, it works. And they pass right through each other. So that's not bad. The only thing is, if the question is when and where do they meet, it doesn't really help too much, does it? So I think what I need to do is think about this time business here. So what's the condition that I could say? And one might say, hey, why don't you test for whether or not the A position is equal to the B position. So let's try that. While, actually I would say while it's not equal to. So I could say while A dot position dot x. Now the not equal to sign is kind of a funny one. It's like, looks like an exclamation mark equals. That's the not equals sign. And again, I just happen to know that because I've had to go and click on help and go look and check it out. So while, oh, and also A is capitalized. I better check that. So while A, the position of A is not equal to B dot position dot x. So while they do not have the same position, do the loop. So as soon as they're at the same position, then stop the loop. Now, I'm not sure if this is going to work. Let's just check it out. We're going to run this here. Coming together, and do they stop? No, they did not stop. So I wonder why that is. So here's something that you can do when you're sort of troubleshooting here. You can put inside the loop kind of like a little test thing. So I'm going to say, well, I'm curious, what are those positions? So I could say, what is A dot position dot x, comma, B dot position dot x. Let's put those both in there, and then we'll look at it here. So they're printing on the bottom. Okay, and then they stopped. Oh, I'm going to have to scroll. I'm going to have to wait till this is over and then scroll way up to find out. Oh, They're never stopping. This is a problem. Okay, if I could freeze the program and go back and take a look, I think what happens is they overlap because of that dt is not perfectly small. At some point they're going to, before they cross each other, they're not going to be at the same spot, and then the next time, the next loop, after we've added just a little bit of v times dt to the position, then they're going to be at the next place. So I think instead of saying not equal to, I could say, well, A starts at 0 and B starts at 12. So A is always smaller than B. So maybe we could say, while A is less than B. So that's going to be true to begin with, because at first A has an exposition of 0 and B has an exposition of 12. And then when that's no longer true, that means that they've passed. So let's try this. Run the program. They're going along, boom, 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 and they stop. Okay, and now actually, yeah, we can see this when I look at it. Here is, this one is 4.62 and 4.74, and now the next one, they've crossed. Okay, so if I wanted to find out where did they cross, it's not great. Like it's not an exact spot, is it? So how about if I do this? This is where I can say, hey, let's make this a little bit more fine. Let's make the steps smaller, and I wouldn't mind knowing what the time was. Print, and I'll put in quotation marks the final time, or the time that they met is, and then I'll go like this, put a comma, put T, right, parentheses, and then maybe the next line, print the position is, comma, and I'll put A, comma, position dot X. And I'll put both of them in there. We'll see how close they are. Okay, hopefully I got that right. Let's run this. And this 30 we don't need to do. Okay. One more time. No error so far. It's a good sign. Okay, and oh, what's my printout? The time they met is 3.34, and the position is 4.676 and 4.652. So here's one cool thing about doing Python is that very quickly we can solve difficult problems. But if we wanted to get the exact value, it's a little bit tough to get it perfect. Isn't that neat how they are overlapped so that they're the same color, kind of? They're a blend of the two colors. Let's do this one more time. Get a little bit closer. I'll say 0.01. I'll run this program again. Still not really slowing down too much. And now it stops, and it is 3.334 and 4.667. So that's very close, right? So we could say the time is 3.33 and the position is 4.67 if we round that last digit. So that's pretty accurate. I think that's about as accurate as we're going to want. Okay, so I hope that this was helpful, and thank you for watching.